After we develop the design of our system, the code we write will reflect the structure of that design. As a review from the last video, one of the definitions of the word class is a template for objects of a particular type. When we design our systems, we figure out what every object needs to know and needs to be able to do. We code the things the objects need to know in instance variables. An instance variable is a variable that is declared outside of any method. When we declare them this way, each instance of the class gets its own copy of those variables.
So the alien class would have an instance variable that can hold a weapon. Each object, each alien in the system, gets its own copy of that variable. So one could hold a ray gun, while another holds a flamethrower.
Nice example. That's how we code what an object needs to know. The other thing we're worried about is what an object of that type needs to be able to do. We code those actions in methods. Here is an example for a simple bank account class. Notice these things. The class is named account. This is the name of the type we are creating. The code inside the class is a template for making account objects. Our accounts need to know their balances, so we've declared an instance variable outside of all of the methods to hold the balance. Our accounts need to be able to do two things: deposit more money and report the balance. It can deposit money using the deposit method. This has a parameter that is how much money is being deposited, and it just adds that amount to the balance in the account. It can tell you what the balance is with the getBalance method. This method takes no parameters and returns a real value that is the amount in its balance instance variable.
Perhaps an example of how we use objects will clarify what's really happening here.
Good idea. So here's a main method in a runnable class that uses the account class we just talked about. First, it declares two variables to be of type account. The compiler of this class doesn't know how much memory an account object needs, so at this point, it just creates space for a reference. This is just like when we declared arrays and didn't yet know how long they would be. We create objects using the new statement. Remember, we used that statement to create space for arrays too. So this is creating a new object whose type is account. The new statement returns a reference to that object, and we use the assignment statement to put that reference into the savings variable. Notice that Java has initialized all of the instance variables of our new object to 0. This statement shows how we call methods in objects. It is telling the savings object to run its deposit method with an argument of $32.13.
So, to call a method on an object, we use the name of the variable, a period, the name of the method we want to run, and then the arguments in parentheses.
Right. This statement will jump to the deposit method. When we go to the deposit method, the JVM will know which object it's supposed to use, so I've shown the savings object here. In addition, the call on the method passed 32.13 into deposit amount, so I've shown that in our memory diagram too. The JVM will get the value in the instance variable named balance, which is 0. Add the 32.13 that we passed into deposit amount, getting 32.13, and store that result in the instance variable of the object it was called on. That puts the 32.13 into balance in the savings object. Then we create a space for IRA using the new statement. Notice that each variable, savings and IRA, points to its own copy of all of the instance variables. We call the deposit method on the IRA object, passing in 23, 24, 23. Just like before, that will jump to the deposit method, cause the value to be stored in the variable named balance. However, this time, we did it on the IRA object, so the value goes into that copy of balance. Then we call the deposit method on the IRA object again. This time, we pass in 333.22. That will make the machine jump to the deposit method again. This time, since we are calling deposit amount on the IRA object, I have shown that object in my memory diagram, and the 333.22 that was passed into deposit amount. This time, when it gets the value of balance, it gets it from the IRA object, because that's who we called the method on. That already contains 23, 24, 23. It will add our 333, 22 to that, getting 26, 57, 45, and store that back into the balance variable. So our IRA object now has the 26, 57, 45 in its balance object. This print line will start a string with savings balance, colon, space, space. Then this plus is concatenation because the left-hand operand is not a number. So then it calls the getBalance method on the savings object. The getBalance method just contains a return statement. Zoomy, what does that do?
A return statement stops the execution of the method and specifies the value that the call on the method should evaluate to.
That's right. So the call on the method will evaluate to the value in the balance variable, 3213. The balance variable of the savings object has a value of 3213. So savings.getBalance evaluates to 3213, and this will print out savings balance colon 3213. Similarly, getBalance called on the IRA object will evaluate to 265745, and this will print out IRA balance colon 265745. When we created an account, it made sense for its balance to start at 0. If you do nothing, all instance variables will be initialized to 0. However, sometimes you want to specify stuff about an object at the moment that you're creating it. For example, say we were building the game Battleship, where each boat has a size that specifies the number of pegs it takes to sink it. It doesn't make sense for a boat to start needing 0 pegs, and in fact, that could cause some weird bugs if we forgot to fix the size of the boat. When you want to initialize an object yourself, you do that in a special method called a constructor. A method is a constructor if it has no return type and the same name as the class. For example, here's a class for that ship in Battleship. It has an instance variable so that each boat can remember how many pegs it needs to be hit with to sink. This is the constructor, no return type, and the name is ship. It has one parameter that is the size of the boat, and it carefully stores that into the instance variable. This is an example of how we would use that to create a ship object. This declares a variable whose name is S and whose type is ship. The new statement will call the constructor passing the 5 into the parameter. The constructor will allocate the space for the object, and this assignment statement will copy that value from the parameter into the instance variable of the object that is being created. The new statement will evaluate to a reference to that new object, and that will be stored into S. So now we have two types of classes. A runnable class has a main method, and that means that it can be run by the JVM. An instantiable class is a template for creating objects. It contains instance variables that each object gets a copy of, and methods for the actions the objects need to be able to do. If you want to initialize some of the values when you create a new object, we'll build a constructor. If we don't do that, the default constructor will allocate space for the object and initialize all the instance variables to 0 for primitive types and null, meaning no pointer, for reference types. There is one other method that every class gets by default, toString. The JVM calls toString anytime it needs to convert an object to a string. For example, if S is an instance of ship and we pass it to system.out.println, the JVM will call the object's toString method and print the resulting string. The default toString method returns a string that is the name of the class, an @ sign, and then the memory address where the object is stored, which just looks like gibberish. If you want something prettier, you can declare your own toString method, but it must be declared exactly public string toString parentheses with no parameters. In that method, you can build any string you want to describe the object. In this video, we talked about how to take an object-oriented design and translate it into code. Each class in our design becomes one source file in our system, and that code is a template for how to make objects of that type. That code includes instance variables that are declared outside of any method, and each object gets its own copy of those variables. In addition, there are methods that encode the actions that objects need to be able to do. Constructors are special methods that allocate the space for and initialize new objects. The default constructor will make all instance variables 0, but we can create our own constructors. A constructor must have no return type and be named after the class. Finally, the compiler will use a class's toString method to convert objects to strings. The default toString isn't very helpful with what it displays, so we often build our own toString to make our output more user-friendly. When we do that, the declaration has to look like this.